Let's take a look at some of the use cases for Nubeva Prism's TLS decryption. First, as a quick reminder, we can decrypt any TLS protocol in Cipher, as well as on VMs, containers, SSL clients, SSL servers. Doesn't matter. We can take a packet capture from any stream, whether that's an Azure VTAP or any other potential mirror in the cloud, third-party packet broker, or even Nubeva Prism's cloud packet broker, or a file replay. Doesn't matter. We take those encrypted packets and we can send them to any tool or to any system. It's completely independent of any tool, and it's going to output an original encrypted stream as well as a decrypted stream for your inspection. Finally, all of this was out using a man in the middle, no application modification, and no certificate or key management. Everything that Nubeva Prisms does, we're a born-in-the-cloud company with a born-in-the-cloud architecture. Scales up to millions of systems, no choke points. Everything at a disruptive price. So let's take a deeper look at some of the use cases. The setup that you're going to see that I've built today is I have one client, my VM over here on the left. It's got a key discovery agent. It's going to be sending all of its keys to a Cloud DynamoDB database. My decryption tool, and I'm going to be using Moloch today. Moloch is a packet capture solution that indexes all the inbound traffic and allows you to sort it based on any number of criteria. We're going to be using that to visualize all of our traffic. The packet stream is going to be real-time using Nubeva Cloud Packet Broker. Now, we're only going to be sending port 443 traffic between the VM and the tool. So we're not going to see anything extra. And that way, any port 80 traffic that we see on our tool, that will actually be decrypted traffic. Finally, all of this is configured from our Prisms Manager. So let's get started. Here's the decryption test that we're going to take a look at. Let's start with the first one. Everyone's familiar with AICar. We've all used it. Let's look at it in an encrypted scenario first. And here we are on Moloch. Moloch is very simply a way to visualize conversations that are happening on your network. In this case, we actually have a filter applied where we want to see the country destination equal to DE, or Germany. And the reason we're doing that is that's where the AICar servers are located. So as we see here, we have a lot of packets that we've gotten in connecting to AICar. And we're going to focus on these two packets right here with the source port of 33814. You'll notice we have one session where the port is on 443, or the SSL port, and the other is port 80. So remember, we're only sending 443 traffic between the source and to my tool. So all of this port 80 traffic actually represents decrypted traffic. First, let's take a look at the encrypted traffic. What you'll notice about the encrypted traffic is we see all of the TLS information, including this is using TLS 1.2 with an elliptical curve Diffie-Hellman ephemeral cipher suite using AES 128 encryption. So this is TLS 1.2 with perfect forward secrecy, and we see all of the certs and all of the encrypted traffic, exactly as we would expect. So now, let's look at this same traffic, this same packet. Again, same source port. And most importantly, the exact same time. If we examine this packet on port 80, now you can see exactly what was requested in plain text, as well as the HTTP request. And most importantly for AICar, we see that special string that's any virus tool, IDS, security appliance of any sort, that will always flag an alert. Let's look at another. So let's look at the second use case. There's a website out there called testmyids.com. It's actually a really good way to test some of your traditional IDSs. The only problem is it's actually an HTTP site. Well, we found a site out there that has an HTTPS variant of that, and we went ahead and downloaded it. Let's take a look at what we see. So here we are back on Moloch again. You'll notice I've actually set an IP destination filter to only show us traffic going to the secure version of testmyids.com. So here we are, we're looking very specifically at this packet from 1731. You'll notice it's the same timestamp, same source port, and again, let's look at the SSL version first. As we break this open, as we would expect, we see TLS 1.2, again, perfect forward secrecy. Interestingly enough, we're using AES 256 here instead of 128. And as we would expect, a perfectly encrypted packet. So now, let's take another look at the port 80 traffic and see what we see. Here we are, getting an testmyids.com file, and we get the HTTP OK. And sure enough, we see a really interesting command that tends to make any IDS pop up and show an alert. So again, in the encrypted version, which is all we were sending, none of that was exposed. Only with Nubeva's decryption agent were we able to expose that potential attack happening. How about another use case? Another interesting use case is AWS API calls. As you probably know, these API calls are actually just simple HTTPS REST API requests. But with SSL decryption from Nubeva Prisms, you can actually see inside not only the request, but also the response. Here we are again, back on Moloch, and let's look at this first query here, which is actually going to iam.amazonaws.com. What we're actually doing here, this is a REST API call simply for get IAM user. And we can tell at the same time, 1736, we have our 443 packet and our 80 packet. So first, let's look at our 443 packet. And again, here we are again, TLS 1.2, perfect forward secrecy. We have all of our certs and all of the encrypted data. Everything we would expect. Let's go ahead and open up and look at the port 80 version and see if we see something a little bit different. Now all of a sudden, we can see exactly what was requested. Here's the HTTP post, the host it's going towards, as well as exactly what the action is that's being required. In this case, get user. And here you see the complete request, and everything actually, if you look at it, you'll see that this resembles the exact JSON format for the output for a get IAM user response. Here's another example. I'll skip the encrypted one this time, but this was actually another REST API call of describe VPCs. This one comes back to us from EC2 instead of IAM, and if we look at the details, you'll see there's my describe VPC action, and sure enough, as you start to look at the VPC sets, you'll notice that is exactly like the JSON output for a describes VPC's API call. So before, where all of that data was encrypted, now it's easy to see what's happening. This gives you a very intuitive way to make sure what actually is happening on your AWS network. Let's look at the last example. And finally, we're going to put our key discovery agent on a server. So it's actually occupying the TLS server side of the discussion. But what you're going to find is it will actually be able to decrypt both sides of the conversation. Let's take a look. So here I have a server running at 10.10.1.7. As you'll notice, I've set my IP destination here at the top so I can see just this traffic. So not only is this the destination of the traffic, this is also the server side of the SSL conversation. This is where we have our agent installed. And as you can tell, we of course are seeing 443 traffic, but we also see the decrypted port 80 traffic. As we look at our encrypted traffic, as we would expect, we're using TLS 1.2, again with Diffie-Hellman 256. We see all our traffic is encrypted. As before, there's no difference. But if we look at our unencrypted traffic, and again, it's the exact same time, exact same ports, you can now see that my source is actually getting an index, just simply getting index.html. And I'm returning the good old-fashioned hello world. But let's look a little closer at that GET request. Generally seeing commands usually involving catting the etc password file is usually frowned upon. So here we're seeing a client-side attack where someone's trying to do some sort of command injection, very simple and rudimentary type of command injection, but we're able to see that very clearly in our server, even though that entire exchange in an earlier packet was actually completely encrypted. Now, with Nubeva Prism's TLS decryption, you can see all of that on clear. Your tools will actually go back to getting the alerts they expect, and you'll have visibility once more. So that's it. You've seen what Nubeva Prisms can do. And as we said, comprehensive capability, game-changing ease and affordability. Nubeva Prism's TLS decryption, we're the only board in the cloud, no compromise solution. Thanks again for your time. It's available in public preview today. Try it for free. www.nubeva.com. Thanks.